Hi guys, so today we're going to look at Chapter 9, starting Chapter 9 and finishing Chapter 9. We will only just cover 9.1. So in this section, we're looking at the reaction of ions in solution, and we want to, from this, determine what a net ionic equation is. And a net ionic equation shows exactly what is reacting in a chemical equation. In order to come to a net ionic equation, however, we must start with what's called the formula equation. And a formula equation shows the formula of each reactant and product in a reaction. So essentially, it's just a chemical equation that you've already learned how to create, and it's balanced as well. So in this case here, we have barium chloride and sodium sulfate produces barium sulfate and sodium chloride. Notice we have the states. Both of these would be aqueous in a double displacement reaction, and from our solubility table we must determine which one would produce a precipitate, and this is necessary for a reaction to take place. Why? Because the fact that a precipitate is formed indicates that a chemical change has occurred. So in this case, if we look at barium sulfate, we would see a solid would be produced. We've also balanced the equation. Make sure that you do that before you continue on to write the total ionic equation and net ionic equation. So what is a total ionic equation? It shows which compounds are soluble, and it breaks them up into their ions in dissociated form. And just like a chemical equation, they must be balanced. In order to be balanced, they have to meet two important criteria. All the entities on one side of the equation must be accounted for on the other, and the net electrical charge on both sides of the equation must be the same. So let's check this out for our equation up top. Let's pull it down again. So breaking up barium chloride into its components, so we say barium, and it's aqueous, plus 2Cl negative with a charge of -1. Notice I put a 2 here as a coefficient. There was a 2 as a subscript. Once they break up into their ions, the compounds then no longer form chloride. We have to put a coefficient in front to indicate that there are 2 of them. Plus 2 NaCl, Na plus plus SO4 -2 produces barium sulfate. Stays together because it was a solid. It will not dissociate. And 2 chloride ions and 2 sodium ions. Now I wrote them kind of backwards, but it doesn't really matter one way or the other as long as they're both there. So this is our total ionic equation. I'm going to rewrite this. Sodium. So we want to show that the net electrical charge is 0. What does that mean? Well, when we learned to make compounds, we looked at the charges of the ions and balanced them out to determine how many of each would be necessary when forming an ion. So we're doing the same thing here. So if we say in this case here we have 1 barium ion with a charge of +2 plus 2 chloride ions with a charge of -1 plus 2 plus -2 equals 0. So that's it. It is it's 0, which shows that it's neutral. The charges are neutral. Same thing for this one. So 2 times +1 plus 1 times -2. And if we add those together, that equals 0 as well. Barium sulfate does not break apart. So we don't have to worry about that. And let's do this for sodium chloride. So 2 times -1 plus 2 times +1. And we get 0 again. Good, so it does meet the criteria that the net electrical charge on both sides is the same, 0 and 0. Perfect. All right, so from here we will create a net ionic equation. So the net ionic equation will show us what's actually reacting. Ions that do not participate in the reaction are called spectator ions. So a net ionic equation is a chemical equation that includes only the entities that react during the reaction. Spectator ions are not included. So how do we determine this? Well, we go and look at our total ionic equation and we see what is the same on both sides and we cancel it out. So do we see barium with a charge of +2? No, we do not. Do we see chlorine with a charge of -1? Chloride ion, sorry? Yes, we do. How about sodium with a charge of +1? Yes, we do. Sulfate? No, we do not. So those are our spectator ions. Sodium and chloride ions are spectating, not participating in the reaction. They'd be floating around in solution. And so I tend to underline what's left over just to make sure that it's correct. So I look at barium sulfate. Yes, barium forms barium sulfate. There we go. That's my net ionic equation. And I'll write that down. Okay, so there's a net ionic equation. This note down here just says that if all reactants and products are soluble and remain, there would be no reaction. So there has to be something forming a solid precipitate for these type of reactions to occur. With double displacement. So this is not limited to double displacement reactions, however. We can also write a net ionic equation for a single displacement reaction. So here's an example. Zinc is a solid. Copper sulfate is aqueous. And we produce copper solid plus ZnCO4 aqueous. Now again, in order for this reaction to occur, the lone metal has to be higher on the metal activity series to kick out the metal that's in the compound. So we would check that to make sure that this is happening. And yes, indeed, this does happen, so a reaction will take place. So we can now write the total ionic equation from this. So zinc is a solid, so it will not, nothing will happen to it. These two sulfates are soluble, so they will break up. So copper has a charge of +2, it's aqueous. And sulfate has a charge of -2, and it is aqueous. Solid, copper stays solid, and then zinc also breaks up. So Zn+2, aqueous, plus SO4, -2 is also aqueous. Now I forgot to check to see if it was balanced. I just saw that it was, so I did it in my brain, but I didn't actually point it out to you. So we do need to do that check. So zinc and zinc, they were good. Copper and copper is good. Sulfate and sulfate is good. So we can look sometimes by inspection really quickly that a reaction is balanced. So now we're going to write the net ionic equation. Therefore, we must cancel what is the same on both sides. So let's take a look here. Zinc. I do have a zinc over here. Is it exactly the same? No, it is not. This is solid, this is aqueous. Cannot cancel it. The same thing holds true for copper. Copper ion is aqueous, copper is solid. And sulfate, yes, sulfate can be canceled. So that's the only thing that will cancel out here. So the true reaction is happening between zinc and the copper. Zinc and the copper ion. And so let's write that out. So okay, so note in this example, the charge on each side of the equation is not 0, but it's the same on both sides. It is -2. So this is something you're going to learn more in grade 12. I'm not going to focus a lot on it right now. So we'll worry about that later. So just all you need to worry about is the fact that you've created your total ionic equation and created a net ionic equation by canceling out the spectator ions, and then that you're doing a good job. So here's some tips on writing total and net ionic equations. We must write the balanced chemical equation for the reaction, use a solubility table to determine whether a precipitate forms, Wrote the total ionic equation by showing all of the soluble compounds as ions. Cancel the spectators and write the net ionic equation. So let's work through a couple examples. We'll have one more example of a double and one more single. So example 1 says, determine if sodium chloride and lead 2 chlorate produce a precipitate when mixed together. So here's our reaction. We're given the complete reaction, so we need to write a formula equation from this. So sodium chloride, and it will be aqueous, lead 2 chlorate, produces lead 2 chloride, and we know that's a solid. You know by looking at your solubility table. Some of these I just get to learn off the top of my head as well. I had to memorize them when I was in school. Okay, so our states are all in, and now we need to see if it's balanced. Sodium and sodium look good. Chloride, nope, there's a 2 here, so I would put a 2 here, which means I got to go back to my sodium and put a 2 here. Let's keep going. Lead and lead is good. Chlorate has 2 in front, so it's all balanced out. So from here we write the total ionic equation, break it up into the ions. And an error that a lot of students make is they forget to carry this coefficient. So when you break up a compound into its ions, you must put the coefficient in front of both parts of it because they're both using it, right? So we would say 2 sodium plus 2 chlorine negative plus Pb plus 2 aqueous plus 2 chlorates. Now in this case, I only put a 2 in front because the 2 was a subscript beside the chlorate, right? -1, arrow PbCl2 plus 2 sodium plus 2 chlorates. Okay, so what's the same on both sides? Cancel it out. Sodium and sodium, gone. Chloride and chloride, nope. Lead and lead, nope. Chlorate and chlorate, yes. So those are canceled out. What's left over? Underline it. Good. So you'll know you did it right if what's on this side that you've underlined makes up what's on the right side. That's how you know it's right. Okay, write that out. Good, and what's spectating? Whatever you canceled out. So our sodium ion and our chlorate ion. Excellent, done that question. All right, one more example. Says write the formula equation, total ionic equation, net ionic equation for the following reaction. Silver nitrate and zinc. So we don't know what the products are. So does this happen? Check it on your reactivity chart or metal activity series. So yes, zinc is higher than silver, so the reaction will take place. And what will it form? I'm going to write that as the formula equation. Zinc is going to displace silver to form zinc nitrate. I need a 2 there, and silver will be all by itself. Okay, total ionic equation, break them up. Oh, is it balanced? I didn't do that part. Silver, silver, good. Nitrate, nitrate, no. Put a 2 in front. Silver has to have a 2 now. And zinc has a 1, so it's good. Break it up. So 2 silvers plus 2 nitrates plus zinc produces zinc with a charge of plus 2 plus 2 nitrates plus 2 silver. What solid stays solid? So cancel out. Does silver cancel? I have a charge of plus and no charge there, so they don't cancel. Nitrates, yes they do, it's the exact same, and zinc. Nope, not the same, so it does not cancel out. So the only thing we cancel out was the nitrate, so we can put that down right now. That's our spectator. And let's write the net ionic equation. Underline what's left. Okay? So as long as you have the same things on both sides, silver, silver, zinc, zinc. Good. So let's write the net ionic equation. And there you have it. That is the net ionic equation. So some questions you can practice. Page 428, I'll just say do 1 to 3. If you want to do more, you have the answers for everything. It's posted. Go ahead. Just like I said, make sure you balance. You write down all the coefficients and show all the states all the way through as well. That's another thing students tend to forget to do. Reach out if you have any questions. Have a great day. Bye.